Hello everyone, this is Muhammad Arif from IT, third year IT, and today's topic is buffer overflow attack. Buffer overflow attack is one of the most common and dangerous security attacks in computer systems. It occurs when the program writes more data into a buffer than it can hold. The data can be overwritten adjacent memory locations, leading to unexpected behavior, system crashes, and execution of malicious code. What is a buffer? Buffer is temporary memory location used to store data while it is being transferred or processed by a computer system. It is it acts as an immediate storage area between different components such as process memory and input-output devices. Buffer helps managing data efficiently by holding it until system is ready to use. For example, when a user types data using keyboard, the input is first stored in an input buffer before program reaches. Similarly, when a data is read from a file or received from a network, it is stored in a buffer before processing it. Normally, in programming languages like C, C++, character arrays are commonly used as buffers. What is buffer overflow? Buffer overflow happens when a program stores more than in necessary data. More than data that is allocated side of the buffer. Since every buffer is fixed amount of, amount of memory, it can hold like limited quantity of the data. If the limit exceeds, then the data from the buffer overflows, and that results to certain functions, variables, and addresses can be overwritten. And because of this, the normal behavior can change, which may cause errors and unexpected results, sometimes even system crashes. In serious case, attackers can intentionally use buffer overflow to insert malicious code and take control of the system. Types of buffer overflow attack. Stack-based attack. A stack-based buffer overflow occurs to stack memory, which is stored functions, calls, local variables, parameters, and return addresses. When a program writes more data into stack buffer than it can hold, the data overwritten nearby memory locations on the stack. In this type of attack, attackers mainly target the return address of the function. The overwriting the return address with malicious code. They can control the flow of program execution. When the program finishes, instead of returning the original location, the program jumps into attacker's code, which allows attackers to run the unauthorized code and malicious code into the system and take the control of the system. Second type is heap-based buffer overflow. A heap-based buffer overflow occurs when heap memory, which is used for dynamic memory allocation during the program execution. The heap stores data that is created using functions like malloc, calloc, and new. This attack when more data is written in heap buffer than its allocated height, the extra data overwritten adjacent memory block. This can corrupt the data structures, pointers, and attackers might take the advantage of that to get the data from the system. They can also manipulate the program behavior, gain unauthorized access, and cause system crashes. Heap-based buffer overflow attacks are often harder to detect than stack-based, making them a serious security concern. And this is an example of buffer overflow and how attackers exploit buffer overflow. Attackers use the buffer overflow vulnerabilities by deliberately providing very large or specifically crafted input data for the program. If the input data access exceed the buffer storage capacity, the data will be overflowed into nearby memory locations, which cause important memory areas such as variables, functions, pointers, and return addresses may be overwritten. By modifying these memory locations, attackers can change the normal flow of the program execution. They may insert malicious code and redirect the program completely, creating harmful instructions and gain unauthorized access to the system resources. In many cases, attackers use this technique to steal sensitive information, install malware, or take full control of the affected system. Prevention technique. Prevent buffer overflow attack. Programmers should use safe input functions such as limit fake. Programmers should use safe input functions that limit the amount of data entered the buffer. For example, functions like fget and scanf with proper format specifiers should be used instead of unsafe functions like get. Programmers must also perform proper bound checking before storing data in memory, which means verifying the length of input, making sure it is within the allocated buffer. And by also checking the limit, programmers can avoid writing extra data into unauthorized memory areas. Finally, programmers should prefer using modern programming languages like Java, Python, GH, which has automatic memory management and reduce the risk of buffer overflow. Finally, buffer overflow attacks are serious threats caused by improper memory handling. Secure coding practices can significantly reduce this. Thank you for listening.